All right, getting into section 15.2, looking at a concept called binomial distribution. So this, in most cases, happens to deal with um, probability of something happening a certain number of times. So this is where you have multiple events, or you're doing an event over and over and over, and we're looking at how many ways you can do something within that event. So let's just take the idea real quick of rolling a single die and having 3 be the number shown. Well, one idea that we're going to be throwing into this concept is the idea of getting what you want versus not getting what you want. So if we were to roll a die and we were talking about the probability of getting a 3, well, if I get a 3, we're going to call that a success. And if I get anything else, we're going to call that a failure. So keep in mind, if I was going to roll a die 5 times, however many times I get a 3 as my successes, and however many times I get anything else would be my failures. So we know the probability of getting a 3 would be 1 out of 6, right? Every number shown on a die, each probability of each number is 1 out of 6. So if we're rolling that die 5 times, and they're calling this event X. So event X is the event, and in this case we're defining event X as the number of times that a 3 is shown. So if we're interpreting this, we're saying that a 3 is going to come up 2 times, is what this is saying. So if you consider rolling a die 5 times, if we're going to say what's the probability that I get a 3 2 of those times, well, that would mean the other 3 times I'm getting something other than a 3. So this is one way to look at it. This is kind of the intro part here, but if I was going to roll it 5 times, and we're going to say 2 of those times we're going to get a 3, so the probability of getting a 3, the probability of getting a 3, this is the probability of anything else other than a 3, not a 3, not a 3. But one thing this doesn't take into account is the order. I don't have to get a 3 on the first 2 throws. I could get a 3 on my first throw and my last throw, and these could be any other number. And so because you can change the order, this creates combinations of getting what you want. And so that's when we have to take into account the number of combinations that could be involved in getting what I want here. So here's the main probability, anything other than a 3. Now this throws in all the combinations of the ways that could happen. So I'm rolling the die 5 times, and we're looking at getting a 3 twice, or 2 specific outcomes, 2 groups within those 5. And so if we throw in the combinations, so I'm looking at this times itself, and then this times itself times itself. So that's where you're getting this picture here. That should be a 3 right there, because I did 5, 6 times 5, 6 times 5, 6. But that's where we get the main formula for what we're doing in this section for binomial distribution. And this is a formula that you do have within your formula packet, and I'll pull that up here in just a second. Here's the way we will tend to see it, and that's what you just saw within that example, but this is the way it's going to show up within your formula packet. So be familiar with this, but notice that, when we see the n over r, this is the way we deal with it, because this is the notation that our calculator uses, but this is the way you're going to see it in your formula packet. Same thing. Let me pull that up real quick. So have these, if you're looking at your formula packet, have this in front of you. These are the 3 formulas. All 3 of these are involved within the current notes that we're doing right now in this video. But here's the one that we just took care of. So just so you can interpret this, this is the combination. So this is NCR. This P is the probability of success. So this is the probability of getting what you want, and this is how many times that's going to happen. This is the probability of failure. So obviously these are complement events, so they do need to add up to 1. And then if this is the number of ways of getting what I want, this would be the remaining number of events for failures. And then I'll come back to those 2 formulas here in just a minute. So anyway, these are the other 2 formulas that you just saw. Within that, one is the mean, and this is the expected value. We've seen this formula already earlier on in the year, but it's now coming up again for binomial distribution. But again, this is expected values. We got the mean symbol right here. So either way you want to say it. This would again just represents the number of trials times the probability of success. And that's all that means. The variance is the mean times the probability of failure. So number of ways or number of trials, probability of success, probability of failure. And then one more formula that you're going to see thrown in but is not in your formula packet, so make sure that you memorize this, but standard deviation. So remember from earlier sections, standard deviation is the square root of the variance. So if I took the square root of this answer, I would get the standard deviation. So here that is within a couple examples. As always, feel free to stop this at any time and try a couple on your own. But here we are with the expected value. So we're going to do something 24 times, so that's the number of trials, that's the n value. And we're still talking about what we did up above in rolling a die. And so this is the probability in all this is 1 out of 6, because the probability of any number when you roll a die is 1 out of 6. And so for the first part, if we just talked about the expected value or the mean value, so if we were to roll a die 24 times and we were to look at the probability of any single number, so if I just said the mean or expected value of getting a 3, then we would say, well, there's 1 out of 6 chance of getting a 3. We're going to do this 24 times, so we would expect to get a 3 4 times out of those 24 events. And because those probabilities are consistent, anytime you roll a die for any number, this would be the expected value for any single number when you were to roll a die. So if I was going to do this 24 times, I would expect to get a 1 4 times, a 2 4 times, so on and so on. When you do the variance, variance is the same formula, but now you throw in the probability of failure. So if my probability of success is 1/6, this is the complement to that, which would be 5/6. So just 1 minus a sixth gives me my probability of failure. So if you throw that into the mix, this is the variance. Keep in mind the square root of this would be the standard deviation. All right, so here we are with the big binomial distribution formula, and this is the other formula within your formula packet. So these are the 3 formulas that are in your formula packet. So again, this is, if we're going to do an event 24 times, this is the probability of getting a specific number on a die 4 times. So as far as combinations go, we got the 24 events, and we're looking for groups of 4 within those. My probability of success for any single number is 1/6, and we're looking for a specific value to occur exactly 4 times, which means my failures, everything else, is going to happen the other 20 times that we do this. And so it's a simple formula. Just throw in the numbers, throw all that into a calculator, and you get your probability of this occurring. Your calculator can do this, and I'm going to show you in a minute here how you can do that. If you want to give this one a try, this is the exact same concept. Again, the standard deviation is just the square root of the variance, but otherwise give this guy a try and see if that's working for you. Here's another word problem. So if Alex beats Boris in chess 5/8 of the time, so they're going to play 10 times, so this is the number of trials that we're going to have right here. So probability that Alex wins exactly 7 times. So keep in mind, this is exactly 7 times, so which means if they're going to play 10 times, he's going to win 7 and lose 3 is what would have to happen there. So again, if you throw in the probabilities that make sense for this, they're doing 10 games. So that's our number of trials. As far as the 7 goes, this is what we want to happen this many times. So we're looking for him to win exactly 7 times. This is the probability of success occurring 7 times, which means he's going to fail the other 3. And so that's where we come up with that probability right there. Again, if you want to give number 4 a try, it's pretty much the same deal. So give number 4 a try and see if that's working for you. All right, so here's where we get into some of the calculator stuff. So if we're going to, again, do something 4 times, the probability that something occurs exactly 5 times or less than 5 times. So keep this in mind, 2 slightly different functions within your calculator that can take care of these 2 examples. whenever we pull up the binomial PDF button, this is the one for something occurring specifically a certain amount of times. This is a cumulative distribution function. So the cumulative is a bunch of things happening. Like when we say less than 5 times, that means it could happen 0, 1, 2, 3, or 4 times. There's a group of events, so we need to use a cumulative distribution function, whereas this one deals with a very specific distribution function, like something occurring exactly 5 times. So this is under your in your calculator. I'm going to pull this up for you. Let me see if I can kind of split screen this here and do both at the same time. Well, let me just go full screen for a minute. So if you go to your calculator, so right here under distribution, so I'm going to hit second distribution. It's towards the bottom, so I'm going to go up to get to the bottom here. So we have those two functions right here for A and B. So again, the PDF is for something happening an exact number of times. The CDF is the cumulative distribution function, so something happening typically when you see the words greater than or less than, and we're talking about a group of events, we want to use the cumulative button. So it's real simple because all you have to do is insert the numbers that they want. So a specific number of trials, you have your probability of success, and then you have the X value. So let me do that with this one here so you can see where all the numbers are coming from. So in this case, we're going to roll a die 24 times, so that's going to be my number of trials. We're talking about the probability of a 3 showing. So if we wanted this to occur 5 times, and again, this is just the formula that we were doing up above, so you don't need a calculator for this. You could do it with the formula from up above, but obviously the calculator's a quicker way to do it. So we want this to happen specifically 5 times. So the probability of getting a 3, or the probability of success, is 1/6. So these are the 4 numbers that I'm going to type into my calculator to get this result that you see here. So as far as doing that, we'd have 24 trials. That's the number of times that we're going to do this. The probability of success. So since I'm looking for getting a 3, the probability of that happening 1 time would be 1 out of 6. So that's my probability of success. And the X value is we want the probability of success to occur specifically 5 times exactly. And so if we just hit enter, there you go. So there's the probability that that would occur. Remember to always use 3 sig figs. So you could either write this as 0.171 or 17.1%. Compare that to what you're doing here on part B, where you see a phrase like less than 5 times. So this is now a bunch of things happening. This is not one specific outcome. This is a group of outcomes. So we're going to use that cumulative button, but otherwise you can see what's going on here. We're just typing in the buttons for the cumulative button. Keep in mind that it says less than 5 times, which means it does not include the 5. If it said less than or equal to 5, then we'd be going up to 5. But in this case, we're going to do the cumulative button from everything up to 4, including 4. And so that's where the 4 comes from. But otherwise, if you go back to your calculator, just choose that other option on your calculator, and those are the numbers that would go in. So again, give a couple of these guys a try. Here's one last thing I want to throw in. The cumulative button does everything up to a certain point. And so when you say something like more than 65, right, that means we're talking about everything greater than 65. When you do the cumulative button in your calculator, it goes from 0 to whatever. So you have to set it up this way in order for that to happen. So we're going to say everything less than or equal to 65, and then subtract that from 1 to get what we want. So this is an important one for any time you're doing more than 65, because again, your calculator does from 0 to whatever whenever you do the cumulative button. So you kind of have to do the complement event, subtract it from 1 in a case like that. But otherwise, that's pretty much it. If you want to give these last ones a try, these are just some more examples. But I encourage you to give those a try in your calculator. If you're having questions, come in and see me. I'd be happy to help you with those.